Hello everyone and welcome to day 5. We're going to talk about even and odd functions, and hopefully may not make sense in the very beginning, but it should make sense by the time this video is done. So when we look at even and odd functions, it says even if f of negative x equals f of x, and it's odd if f of negative x equals negative f of x. So what this is actually saying is we're going to plug in negative x, and if it equals the original, then it's even. If we plug in negative x and it equals the exact opposite, meaning all signs changed, then it's odd. If we look at exercise number 1, it's good to be able to read mathematical definitions and theorems as you advance into higher level mathematics. So we're going to look at the definitions above and try to determine what they say about the inputs. And I basically just did that for you. So you don't have to think, which is not a good thing. But even functions. We have plug in negative x, get original back. Plug in negative x, all signs change. So let's look at what even is. Remember what we said, we plug in negative x and we get the original function back. So if you're given the points 0, 0, and notice that they're below here, 3, 5, and 7, negative 2. That's where I got them. They're right here. If I plug in negative x, well, what's negative 0? Still 0. I'm going to do this in red for you. So f of x was the original, green. We're going to go red. So negative 0, and I get back the original 0. Well, we know that that just implies 0, 0. So let's plot that, 0, 0. I plug in negative x, which gives me negative 3, and I get back the original, 5. That's a 5. So negative 3, 2, 3, up 5. In the last one, I plug in negative x, so negative 7, and I get back the original, negative 2. I connect them. Poorly drawn last line there. But what happened? How does the red compare to the black? Now I'll let you think on that one while we go to the odd. So keep thinking while we look at the odd one. Remember that in odd, we plug in negative x, and we get back the opposite sign. So we get negative 0. So that's still 0, 0. So we'll put a dot at 0, 0. We plug in negative x, negative 3. We get back the opposite sign for the y value, negative 5. Plug in negative x, you get back the opposite sign for the y value, positive 2. So 1, 2, 3, down 5. And 7, positive 2. So what symmetry happened here? What happened in the even? How was that, what symmetry was used? How was that even maybe reflected? And so for even, it's reflected over the what? Y-axis. And odd may be a little more difficult to see. This should Once I say it, you should be able to see it a little bit here. Everything's reflected over the y-axis. Odd's a little bit different. Odd is symmetric about the, if you don't remember this, I don't think it's going to matter if I sat here and waited for you. Symmetric about the origin. What does symmetric about the origin even mean? You're probably thinking to yourself. Symmetric about the origin means that it's reflected. What does it mean? It's reflected over the y-axis and the x-axis. Okay? So reflected over the y-axis here. So if we go here, reflected over the y-axis to here, and then the x-axis down here. Or in this case, reflected over the y-axis all the way over, and then the x-axis up here. It doesn't matter which order you go in, as long as it goes in one of them. As long as you do both of them, excuse me. As you do both reflections. So I want you guys to take your time and pause the video and do exercise number 3. It says, actually you can skip A, but I want you to do B. Sketch f of x equals the absolute value of x minus 4. You shouldn't need your calculator because you know what transformation this is. And then tell me if it is even, odd, or neither. So pause the video. So here we are. The answer to exercise number 3 is even. It was symmetric over the y-axis. And if you pause it and write this down, I also showed you how to do A. Plug in 3, you got -1. Plug in the opposite x value, you'll still get the same y value. So you can pause that and copy that down. The next part that we will look at is the x cubed minus 4x. So what I need you guys to do is, if you have a calculator, or you can try to do it in your head, to fill in A. And if you don't have a calculator, or you can't do it in your head, or you're just too lazy to, pause it. Don't pause it, and you'll just have it. And so there are the answers. Pause the video, and now graph this. And this is what the graph should look like. Hopefully that's something that you guys got something to resemble that. The goal of this is what we want to see here is that when you plugged in -3, we got -15. What happened when we plugged in +3? The answer is that we got +15. The signs changed. You plugged in -1, you got 3, 1, you got -3. The signs changed. Therefore, what you should be seeing here is that this is an odd function. And why? When plugging in -x, the y value was also negative. Or over in B, you can say this is symmetric about the origin. Notice that I can take here, reflect, and get the same, and get to that point. Here, reflect, and get to that point. So 2 to the x, I'm going to help you out here. I'm going to make a table for you. We're going to start at -2, -1, 0, 1, 2. This is all you should need to see. -2, you're going to get 1/4. -1, you're going to get 1/2. You can get 1 here, 2, and 4. Take a minute and write down the answer when you pause it of whether you think this is odd, even, or neither. So pause it, please. And hopefully you guys got neither. And here's my reasoning. Because 2, 4 does not equal 2, 1/4 or 2, -1/4. And the reason why I wrote that is because when you plug in a -2, you get 2. And it needs to equal either 1/4 or negative 1/4 for it to be even 1/4 or odd to be negative 1/4. And you don't get that. The 2, 4 is the actual point that we get. So that's my reasoning. You may want to write the explanation in there if you don't get that. But if you plug in a negative 2, if I negate negative 2 to get positive 2, the point that I get is 2, 4. And it needed to be even, odd, or even. It needed to be the same y value or the opposite y value, and that's not the case. We are going to stop here, so I will see you in class to finish up the notes and work on some practice problems. Enjoy your day.